Okay, here on example number 4, we're going to go through and do one of these trigonometric functions of a quadrantal angle. So it means one of those angles that are leaving us right on the dividing line of our quadrant. So they give us the point -5, 0, which would be right here. They basically just want to say, like, well, first of all, that's a 180-degree angle, right? It goes a straight line. So they want to say, what's the sine of 180 degrees? What's the cosine of 180? What's the tangent of 180? And what's our cosecant, secant, and cotangent of that 180-degree angle. Now, what's difficult is when you have that 180-degree angle, the right triangle that you are imagining is now just a line. There's actually like no triangle to speak of at all. So what I'm going to do is I'm going to actually just draw a really thin triangle, and what I'm going to do is I'm just going to have you imagine that this side right here of that triangle, we're getting to the point where that side, which is the green line on this interactive unit circle, that green line is getting smaller and smaller, and eventually where we want to be is where that side is 0. I'm going to draw it actually having some physical height, even though that's not accurate, right? It should just be a straight line. But in order to understand where our opposite side is and our adjacent and our hypotenuse, I'm going to draw it like it was an actual right triangle. So our opposite side would be a side with a length of 0, that green line right there. And our hypotenuse, which in the interactive unit circle where my mouse is, the hypotenuse is the gray line and the adjacent side is the blue line. Well, as they come together, they should both have the same exact value. They should be the same length. So I'm just calling that x and x. Now, in this case, that x distance would be that -5 number. So I'll put that on both of these. Okay, and then we can go through and kind of go from there. So when they say sine, that's opposite over hypotenuse, which they're saying is that y length over the hypotenuse, which they labeled r above when we were working on that earlier example, which was kind of like, I think, just supposed to mean radius. So that opposite side was 0. The radius side was 5. Let me think about this one second. So why are we doing +5 and -5? Well, this one should be +5. I guess that makes sense because the way that we should get this number is going to be 0 squared plus -5 squared. So that's going to give us 25. Shoot. Sorry guys, sometimes I get a little bit thrown off on this. This is something for me to kind of figure out a little bit better with these negative and positive signs. It just seems like I'm not always 100% on top of when I'm expected to be using a negative or a positive on some of these things. Typically, I'm used to just not using negative values for distances at all, but within the unit circle, we do need to specify if we are going in the x direction to the left or to the right. So I guess that makes sense to use a negative sign there. Here, with the, like, what I'm going to call this radial line, there's not really a positive and negative direction for that line, right? Because it's not along one of our axes. It's moving diagonal to the axes. So there's not really a reason to say this is a positive or a negative. So I guess positive is as good as anything else. All right, so for the sine, we'd be doing the opposite side over the hypotenuse, 0 over 5. For the cosine, we'd be doing the adjacent over the hypotenuse. For the tangent, we'd be doing the opposite over the adjacent, 0 over -5. Then for the rest of these, we'd be flipping those around. So, wondering why I'm seeing a 4 here. That doesn't seem right. I think that might be a typo. I think that should have said 5 over 0, right? It should be this one flipped over. Let me just think about that for a second. Yeah, that should have been a -5 over 0. This one should be a 5 over a -5. That looks good. And that one should be a -5/0. Okay, so that all checks out. So anyways, when we are right along those axes, when we're at those quadrantal angles, this is kind of what I would recommend imagining. Just kind of follow along with that idea of moving that right triangle along the inside of a circle, keeping one of your legs on the x-axis at all time, that blue leg, the adjacent side, and just kind of imagining what we're talking about when we reduce that opposite side down to 0. So we're kind of dealing with an image that I'm sort of fudging a little bit with this drawing here, but I think that kind of helps us keep in mind which values go with which vocab terms, which side is the opposite side, which side's the adjacent, things like that. Okay, so that is it for example number 4.